Good morning, everybody. I'm Nathan Doty, CEO of Asite. I'm here to talk to you this morning about engineering digital twins for a vibrant society. So a little background about me. I've been with Asite for nearly 20 years. I was the original founding CTO, so the guy who started building the platform at Asite. I've worn quite a few different hats over the years and within the group, and most recently CEO. Prior to Asite, I was also in construction technology. My background to get to that point was basically a typical American dilettante style of education, doing a little bit of everything, studying computer science, architecture, urban planning, and then finally getting a degree in English literature. So a non-traditional background perhaps, but one that I feel has helped me to have a broader perspective on what we do together as an industry. We've got a bit of a big picture to talk about here this morning from me, leaving aside some of the levels of detail which are fundamental to how we all come together and collaborate to deliver a better built environment. I want to talk at a high level about the outcomes that we can all achieve together to improve our built environment around us and the infrastructure that underpins that, so that we can all leverage and make better use of that to have a more vibrant society together. And that's right the way across the world, in every economy, whether it's fully developed or developing, at every level. So digital engineering is a major theme for what we at Asite and we in the broader built environment are trying to deliver. But what does it actually mean? I mean, fundamentally, we know what engineering is, or there's, we know that there are a variety of different disciplines within engineering, from civil engineering to structural engineering to electrical to mechanical, et cetera, et cetera. So the practice of engineers in effectively designing and making things, if I can use that word, is well understood and ever evolving, and a very professionalized discipline within our industry. So digital engineering, quite simply, is the digitization of that practice, right? So when we work to create, deliver, and make these things around us, the buildings that we're in, the roads that we drive on, we deliver an asset which gets operated. But what we also need in modern times to be focused on delivering at the same time is the digital version, or what we call the digital twin of that asset. Stepping back from a process perspective, what you're basically saying is that we're now requiring of our engineering discipline not only to design this thing, but to also create the data architecture, the data that underpins it, that is the digital representation of that thing. That's quite an ask. That's a big ask, because the discipline of computer science, software engineering, data science, these disciplines have heretofore been pretty much wholly different and separate from traditional engineering. We're talking about melding and blending these two things together into one practice. So that's a major shift in our industry, and one that's I'd say at the beginning or near the beginning and ongoing. This idea of digital engineering is not like a light switch that we can flip. It's not a snap your fingers instant change. It's a journey, and it's a journey that not one individual will take alone, but that we all, as collaborators, colleagues, industry peers, and project team members, will take together over time. So I've highlighted here in the presentation today a few key areas of technological focus that we see in the industry that all have a part to play in this journey. I'm going to talk about 5 of those today, and they're flowing kind of one into the other in my view, in the mirroring the life cycle of the built asset. Starting with BIM, Building Information Modeling, moving in to talk about advanced building materials, the things that we build with, right? a little bit on modern methods of construction, effectively the manufacturingization of the building trade, delivering smart buildings which can be connected to the digital twin, right? i.e. the work product of this data science approach to the building trade. The fundamental underlying definition of BIM that sticks and resonates with me is always this semantic description of your building, right? So, and that semantic, can be a fancy word, but it just basically means meaning, right? So, a meaningful, structured database that underpins your building, right? Many people correctly also point out that BIM is not just a thing, right? A database. It's also a process, right? It's also the process of how we all come together and collaborate, collaborative BIM, to build that meaningful database. One of the catchphrases that we all have heard and really resonates with me as well is this idea of effectively the golden thread. So whilst we're in this process of building up and collaborating and changing the way we work in order to achieve a meaningful structured database, we are effectively building the beginnings from the very early phases of conceptual design. We're building the beginnings of this golden thread that will snake its way right through the process until we're actually living in and inhabiting the physical infrastructure around us, right? And being able to connect back to that idea that we started with and the data that got added in when, the trade contractor came onto site to install the doors, right? It's, for example. So that idea of the golden thread begins here with the process that we put in place to work together to define data. One of the key underlying themes of this process change is that we've got the physical and we've got the digital. In order to be effective, they need to be intertwined. So, how do we do that? There's a lot going on, around us, in terms of the efficiencies of our process, pressures on us from procurement, changing worlds around us and changes in the way that we use space due to COVID-19 and other concerns globally. Paramount amongst those is the impact of our built environment on sustainability and on the environment of the world. One of the key areas of innovation here that we see is in the actual materials that we use. The significant portion of us who are in the product and building materials spaces, we are seeing some significant improvements, both in terms of the manufacturing processes that generate these materials, but also the ecological impact of them, but all the way right through to baking in the idea from the beginning of the manufacturing process that this physical thing, right, whether it's a roof tile or a door, window lintel or a door frame, this physical thing will need to be connected to the digital world as well. So then if you have that idea from the beginning, you can take steps in your manufacturing process to embed sensors, embed the ability to emit and receive data feeds or data flows. Let's just remember that across this whole life cycle, every participant in the supply chain has a significant part to play in digitizing. So we got the idea of a database from the beginning. We've got the manufacturing and product-centric elements of the construction process starting to think about digitizing their materials from the beginning. And then we start to look at how is it that we actually come to site and build the building or the expo hall or do the road works that we need to do. Now, particularly when we're talking structures, we all who those of us who've studied architecture in our industry or design will know that we come from centuries of tradition, wherein the archetypal idea of the designer and architect was this kind of Renaissance builder, right, who effectively owns the process from the beginning and is really creating a unique and artisanal work of art, effectively. In the modern world, the challenge that we face here with digitizing, I think, is that we need to still maintain our ability as humans to express ourselves through our built environment, but also incorporate more modern ways of working, i.e. manufacturing. There's a lot of body of work out there that is concerned with how we can take the construction industry and bring in, more repeatable ways of building the things that we build. So offsite construction, prefab components that can be brought onto site and effectively stitched together like Lego. All of these things have more than just practical use. What they also do is they regularize the process by which we build, which enables us to better predict outcomes. Right? And again, back to my kind of basic thesis here, better build in the ability to marry data to that process. If you have a database and you have smart building materials and you're using a regular, predictable, manufacturing-based construction approach, you can then produce smart buildings, right? So what is a smart building? I mean, it's quite simply, again, a building or any infrastructural asset that has the ability to connect to data, right? To send data and to receive data about itself and about its environment and about the occupants of the building. The Internet of Things is, a term that we've all heard. Is the idea that every asset or every significant asset within the building that I'm in today has that bidirectional data receiving and sending functionality baked into its very core. And once we effectively have that as a network, we then have the ability to link that back to the data model, right, to the BIM. That linkage now between the smart building and the data model or the database, the BIM, is what enables us to deliver what we're all trying to deliver here, a digital twin. So the difference between a BIM model and a digital twin is quite simply that digital twin is connected to the asset, where if something changes in the real world, the digital version or digital twin can be informed of that. If there's information in the digital twin about, say, the warranty of a desk that we installed into a space, that can be picked up in the physical world by the actual facilities maintenance woman who's on site to look after the desks, right? And that kind of connectedness is what's the signature of a digital twin, and it really brings that golden thread all the way through from the idea where we started into the operation of where we are right now, the building that we're in today. There's a lot of moving parts there, and I've only picked a few really headline, quite well-known areas of technology that are important to this. There's so much detail. I've seen personally over the past 20 years, so much good work by so many different types of people, from technologists to builders to engineers to commercial people, all across the board, in effectively defining how we might work together, how we might collaborate more effectively, using standardized approaches and using commonly understood or shared standards for communication, both verbal, traditional communication as well as digital communication. So what I see that the industry really needs in order to enable this is one common platform, and that platform needs to be open. It needs to effectively be from a data or geeky technologist perspective, it needs to be an open ability to send and receive and capture and store, share and collaborate all the data that we're generating. That's not something that I believe that's going to be successfully created and delivered as a proprietary platform. It needs to be something that is open and available and doesn't lock in the industry. And it needs to be based on these open standards, both in terms of communication as well as data structures themselves. So that platformization of what the industry needs, I see as the kind of the next big thing. Industry 4.0 for the construction industry. We talk about enterprise service bus, which is as a technology, the ability to build connectors that are open to any type of system. I see that idea needs to be expanded out to become the industry service bus for the built environment. And it's part of our mission and my personal mission to do our part, trying to help the industry, all of us get to that point. But as I said, it's not just one of us, it's all of us that need to be involved. The outcome of that, I believe and hope, is that we can build more vibrant, better for all of us, better to live in, more supportive of our people, friendlier to the Earth's environment, and more resilient societies. Right, shelter, food, and water. Right, the three basic necessities of human life, and our industry is about delivering one of those. Right, shelter. So fundamentally, the more effectively and more efficiently we do that to encourage all of us to share these spaces and live together better, makes us more resilient. And resilience has taken on new meaning and new impact this year globally because of what we're all going through with COVID and lockdowns. And I know changes that you put in place today, you may not see them take effect immediately. They may not be in effect tomorrow, but if you start to act and start to bring these ideas in, then next year, 2 or 3 years down the road, we start to see results coming into play in the actual physical world that we create. And that to me is super exciting. That's it for me. Thanks for listening, and enjoy the rest of your day.